the last one, that is quantum numbers. Okay, the quantum numbers are of four types, that is principal quantum number denoted by n, azimuthal or angular momentum quantum number denoted by L, magnetic quantum number denoted by M, and spin quantum number denoted by S. Okay, before we move on to the quantum numbers, I'll give you one task. Okay, I want you to go through the difference between orbit and orbital. Okay, now coming back to the quantum numbers. Okay, quantum number gives you the information, okay, about the state of an electron. Okay, it describes about the energy level, it will describe about the subshell, the angular momentum, the orientation, okay, the magnetic property, and also the spin of an electron. So the first one we have is the principal quantum number. Principal quantum number is denoted by the symbol n. Okay, now the principal quantum number determines the main energy level, or it describes about the main energy level called the shell. So the n can have the possible values, that is 1, 2, 3, and so on. Okay, this 1 is the first shell, 2 is the second shell, 3 is the third shell, and so on. Okay, so we can say the first as k shell also, okay, respectively k, l, m, and so on. Okay, now when we talk about the energies of each level, okay, so the energy of each level increases, okay, with the increase in the number of energy levels or shells. Okay, so the order of the energy will be, suppose this is the energy of the first level, so the order will be of this. Okay, now in order to calculate the maximum number of electrons that can be accommodated in each cell is given by 2n square, that is the total number of electrons that can be accommodated in each cell is given by 2n square. Now if n is equal to 1, if n is equal to 1, then total number of electrons will be equal to 2 into 1 square equals to 2 electrons. Okay, so I want you to find out, okay, the total number of electrons that can be accommodated if it is for the second shell and also the third shell. Okay, the next one is the azimuthal quantum number. Azimuthal, or it is also known as angular momentum quantum number, that is denoted by the letter L. Okay, so it will describe about the shape of the subshell, okay, and also it will give the value of the angular momentum of the electron, and that will be in terms of h by 2 pi units. Okay, then L can have the values 0, 1, 2, 3, and so on up to n minus 1. Okay, now if L equals to 0, then it refers to S subshell. Okay, if it is 1, it refers to P subshell. Okay, it is also called S orbital, P orbital, and so on. Okay, so D orbital and F orbital. Okay, then it will go on. Okay, now see, if n is equal to 1, then L equals to 0. Okay, it will be one value less than that of the n. Okay, if n is equal to 2, then L can be 0 as well as 1. Okay, so here in the first shell, okay, n refers to the shell, then the number of subshell will be only 1. Okay, if it is the second shell, then the values of L is 0 and 1. That means there are two subshells. Okay, so one is called the S, the other one is called P. Here it is only S. Okay, and if n is equal to 3, okay, then L will be 0, 1, and 2. So all total 3 subshells are there. So it's equal to S, P, and D. Okay, these are the 3 subshells or orbitals. Now see, this one we write it as, okay, 1s, this one we will write it as 2s as well as 2p, okay, and this one we shall write 3s, 3p and 3d, okay. Here this refers to the shell, okay, so first shell and the subshell or the orbital is s. This one second shell, s orbital, second shell, p orbital, and so on, okay. Now regarding the energies of each of the subshell, okay, so the energy will be of this order, okay, that is, see, s less than p less than d less than f, okay, the order of the energies will be of this order. Now the next one is magnetic quantum number, okay, it is denoted by the letter m. This will give you the information about, or it determines the orientation of the orbitals in the space, okay. Now the magnetic quantum number can have all integral values from minus L to plus L, okay, including the 0. Now for a given L value there are 2L plus 1 values of m, okay. So let us see, if L equals to 1, okay, then m is equal to 2 into 1 plus 1, so equals to 2 ones are 2 plus 1 equals to 3. A total of 3 orientations will be there. So let us see how they are, okay. So what are those 3 orientations? We have plus, minus 1, 0 and plus 1, okay. You could have written plus 1 here also, it's okay, okay. So if L equals to 1, m will have minus 1, 0 and plus 1, which is equal to 3, isn't it? So 3 orientations, okay. So see, in the previous quantum number, that is the azimuthal quantum number, 1 is referred to as p subshell or p orbital. So the 3 orientations are px, py and pz, okay. So the orientations will be along the 3 axes x, y and z, okay. And if L is equal to 2, okay, if L is equal to 2, if L is equal to 2, then m will be equal to 2 into 2 plus 1, so it's equal to 5, isn't it? So a total of 5 orientations will be there. So m is equal to, what are those 5? Plus or minus 2, plus or minus 1 and 0. So say 1, 2, 3, 4, 5, isn't it? So these are the 5 orientations. Now L, if L is equal to 2, we represent it by D, okay. So the orientations are dxy, dyz, okay, dzx, okay, dx square minus y square and dz square. So these are the 5 orientations, okay. The next one is spin quantum number. It is denoted by the letter S, okay. It describes the rotation of electron about its own axis. The values that a spin quantum number can have are, one is plus half, the other one is minus half. Plus half is for clockwise rotation and minus half is for anti-clockwise rotation, okay. So we also represent, okay, the clockwise as the, okay, this way. So for clockwise the arrow sign will be pointing upward, and for anti-clockwise the arrow sign will be pointing downward, okay. Now let us see a combination of all the 4 quantum numbers, okay. So let's take an example. If n is equal to 2, which refers to the second shell, okay, then L can have 0 as well as 1. Here 0 refers to the s orbital, 1 refers to the p orbital or p subshell, okay. Then m is equal to, for L equals to 0 we get equals to 1, only one orientation. Okay, for L equals to 1, we get 3 orientations. Okay, which means 3 orbitals. Okay, the one is called px, py, and pz. Here only one orbital. Okay, 3 orientations, so 3 orbitals. Okay, then the spin quantum number. Okay, so in this orbital there are maximum 2 electrons that can accommodate. Okay, in this px orbital, s equals to plus minus half. For this also plus minus half. For this also plus minus half. Okay, so now see, by calculation, okay, from the formula we know that in order to calculate the total number of electrons in the main energy level or shell, we use this 2n square, isn't it? So here n is 2, so 2 into 2 square equals to 2 into 4 equals to 8 electrons. According to the formula, in the second shell a total of 8 electrons should be there. So let us see whether it satisfies or not. Okay, so see here 2 electrons, one is plus half, another half, so 2, here also 2, here 2, and here 2, isn't it? So a total of 2 plus 2 plus 2, so equals to 8 electrons. Okay, so total number of electrons that can be accommodated in second shell is 8 electron, and by formula also we got 8 electron. Okay, now the next one is, okay, I'll give you a problem, you try it for n is equal to 3. Okay, so by formula total number of electrons will be equal to 2 into 3 square is equal to 2 into 9 is equal to 18 electrons it should come. Okay, so you try out.